In this organic chemistry tutorial screencast, we're going to look at alkane nomenclature. The first thing that I want to do is list the basic carbon units starting from 1 through 10. So here we'll have number of carbons and then the associated name for the alkane. So this is methane. So CH4. 2 is ethane. We have CH3, CH3. 3 is propane. CH3, CH2, CH3. 4, C4 is butane. CH3, CH2, CH2, CH3. 5 is pentane. So I'm going to start drawing these in the bond line formula. So that makes it a little easier to convey that information. So you can see the terminal ends are CH3 groups, and then in the middle we have the CH2 or methylene groups. 6 is hexane. 7 is heptane. 8 is octane. 9 is nonane. 10 is decane. So those are the basic C1 through C10 names that we'll want to know to determine the names of other organic molecules for simple alkanes. So the exercise that I want to start with ties in a couple concepts. And so what we're going to do is given a molecular formula, so we'll start with C5H12. And so this is going to be a saturated alkane that obeys the general molecular formula of CnH2n plus 2. So here is N is 4, 2 times 4 is 8, plus 2 is 10. So this is a saturated alkane. And the problem that we want to do is determine all the constitutional isomers we can for that molecular formula. Knowing that there's no degrees of unsaturation, every carbon has to be sp3 hybridized. So a logical way to do this is let's first start with, let's write C4. And basically what we're saying is that the longest carbon chain has to have 4 carbons. And then if we count, we have CH3, CH2, CH2, CH3. So we've accounted for all the hydrogens in that chain. Let me go ahead and point out, this is again called butane. And some other things to point out with this molecule is that the hydrogens of a methyl group can be classified as being primary. The hydrogens of a CH2 or methylene group, we can call them secondary. So butane actually has 2 unique type of carbon and hydrogen. We have primary hydrogens and secondary hydrogens. So within the C4H10 molecule, there's also another isomer that we can draw. We've pretty much used up everything we can for the C4 chain. So let's go down 1 to a C3 chain. And so what we're going to do is draw 3 carbons, and now we have a remaining carbon that we have to add. We can't add it to either terminal carbon because then we just get back to butane. So really the only thing we have to do is, what we can do is add it to the middle carbon and put it there. So now we have a C4H10 isomer. And this has a different name. And so this illustrates the exercise of why nomenclature is so important. Given the same molecular formula, you can have constitutional isomers, so they have different connectivity. So the molecules have to be named different. So how would we name this? Let's arbitrarily start here and call this 1, 2, and 3. So we have a 3-carbon chain, so that's going to be a propane derivative. And we can see at carbon 2, there's a substituent CH3 group. So we're going to call this 2-methyl propane. And so we can see if we classify these, we have primary hydrogens, and now this carbon only has 1 hydrogen, so this is going to be a tertiary hydrogen. So as we start layering these concepts about uniqueness of carbon and proton, we classify the carbons and the protons. This is going to help us when we start actually learning about CH activation with radical chemistry. Let's go ahead and look at another example. Given the molecular formula C5H12, so notice we've increased 1 carbon and we've added 2 more hydrogens, and that follows our general formula CnH2n plus 2. And if we're logical about what we do here, we're going to draw the C5 chain first. So again, this is going to be pentane. So we can only really draw 1 molecule with a C5 chain. So we have primary, secondary, and secondary type hydrogens. So we can drop down to a C4 chain. 1, 2, 3, 4 carbons. Now we still have a methyl group, a carbon to put in. We don't want to put it at the end because that gives us to pentane. So let's put some numbers in here. There's our 4-carbon chain. We wouldn't want to put in the methyl group at 1 or 4 because then we're just going to make pentane again. So if we put it at carbon 2, we've now made a new compound, which is a butane derivative. So the longest carbon chain has 4, and at the 2 position we have a methyl, so we would name this 2-methyl butane. We have primary, secondary, and tertiary type hydrogens. So we can even go one further down to a propane, a C3. So here we have a propane derivative. And now what we have to account for is 2 carbon groups. You're going to see that we don't want to add to either 1 and 3 because that's going to get us back to a C4, or potentially if we do both 1 and 3, the C5 chain. So really the only thing we can do is put both carbons at C2. And so because this is a propane derivative, we're going to name it as such. And both substituents are at carbon 2, so we say 2,2-dimethyl propane. So let's look at one more, and then we'll summarize the basic rules for nomenclature. We're going to continue our trend here. Let's look at C6H14. The C6 chain, again, that's just going to be hexane. We can't do any other sort of constitutional isomer once we have that C6 chain in place. So let's drop down to the C5 chain. So this is going to be a pentane derivative, and we have 1 carbon to put in. Let's be methodical about this. There's our chain. We can't put the methyl at C1 or 5 because that gets us back to hexane. So let's go to 2. So this would be 2-methyl pentane. So an exercise we forgot to do up here: primary, secondary, secondary. Down here, primary, tertiary, secondary, secondary, primary. So that's, again, that's the classification of those types of hydrogens, which is important later on. So for that compound, we put the methyl group at C2. What about moving it to C3? We can do that as well. We put the methyl group at 3. We've now made another compound, 3-methyl pentane. And so if we classify these, we have primary, secondary, tertiary, and primary. So in addition to figuring out the unique type of hydrogen, we can also classify them. And that's, again, that's important when we start doing radical chemistry. So we've exhausted our C5. Let's go down to C4. So again, we're going to draw 4 carbon chains. Let's number them. So now we have to put in 2 carbons. Again, we don't want to start at 1 or 4 because that's going to increase the total chain length, getting us back to a pentane derivative. Let's put both at C2. So we would name this 2,2-dimethylbutane. Let's go ahead and characterize or classify the hydrogens. These methyl groups are all equivalent. They're all primary hydrogens. This carbon here at 2 is bearing no hydrogens. We have 2 hydrogens, so that's secondary, primary. We can go ahead. One more butane derivative. In the first case, we put both methyl groups at 2. We can put 1 at 2 and 1 at 3. So this is going to be 2,3-dimethyl-butane. And this only has 2 types of hydrogen. You have primary and you have tertiary. So to briefly just sum up the rules for nomenclature, you want to find the longest carbon chain. That's going to give you the parent hydrocarbon in which you're naming the molecule. Substituents are bonded to that chain. And so they're named, in this case for alkanes, you're basically dropping the ANE and you're changing it to YL. So methane becomes methyl, ethane becomes ethyl, propane becomes propyl, etc. And then you're going to number the location of the substituent. So that's an oversimplified explanation of the rules. But as practice, what you can do is say, given a molecular formula, say we wanted to go up to C5H12, you could go through this exercise again and practice naming the alkane constitutional isomers in that molecular formula.